Welcome to the video for Chapter 8, Quadrilaterals, Lesson 3, the tests for the parallelograms. By the end of this lesson, we should be able to answer the question, how can we tell if a quadrilateral is a parallelogram? So this is different than the last lesson because the last lesson, all of the quadrilaterals were given to you as parallelograms. Now you're going to be given quadrilaterals that may or may not be parallelograms. The job is to figure it out. We learned in the second lesson that if the quadrilateral is a parallelogram, then both pairs of sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and that both of the diagonals bisect each other. Today's lesson, we have their converses, which remember means that we can flip it and say that if any of the above 5 things are true, then the quadrilateral is a parallelogram. So again, number 1, opposite sides are parallel. Number 2, opposite sides are congruent. Number 3, opposite angles are congruent. Number 4, consecutive angles are supplementary. So remember the S and the L stand for small and large angles. The small angle plus the large angle will always equal 180 degrees. And then number 5, the diagonals bisect each other, creating 2 sets of congruent segments. In addition to those 5 things working both ways, there is also a new property, a new test that if we have this set of information, then we can say that the quadrilateral is a parallelogram. And that is that if one pair of opposite sides are both parallel, which remember that looks like the arrows, and congruent, which remember are the tick marks, then the quadrilateral is a parallelogram. Again, focusing on the fact that this is one pair of opposite sides, so it has to be that same line, those same sides of the quadrilateral have to be marked as parallel and congruent. We don't need any information about the other pair of sides or any angle information. This is all we need in order to say that the quadrilateral is a parallelogram. So the examples are just going to be asking if the quadrilateral is a parallelogram, and if so, we're going to justify the answer, just explaining where this answer is coming from. So this one, the opposite sides are congruent. So because they're congruent, we can say yes, and we'll just say opposite sides are congruent. This problem says which method would prove the quadrilateral is a parallelogram. We have it marked as 15, which means that it's congruent. We have the arrows, which means that it's also parallel. And so this would be that new property that states that yes, this is a parallelogram because the same pair of sides is both congruent and parallel. So the other type of problem we're going to see in this lesson is where we are being asked to find a value for x that would make the quadrilateral a parallelogram. We have seen problems like this before back in the chapter that dealt with proving the lines being parallel or not, where we had to find a value of x in order to make that happen. And remember that when we do that, it's really just assuming that it is what we want it to be. So we're going to assume that this is a parallelogram. So we want the opposite sides to be congruent in order for that to be true. So we're going to assume that they are, set them equal to each other, and find that value of x that would make them equal to each other, and therefore make this quadrilateral a parallelogram. So again, using the fact that we're assuming that this side is congruent to this side because we want to find that value of x that would actually make them congruent to each other, I'm setting the equations or the expressions equal to each other, solving. The right-hand side does need simplified with some distribution, and then I'm just going to go ahead and do this in one step here. I'm going to subtract 3x from both sides, and I'm going to add 1 to both sides, and that allows me to get x by itself and 7 on the other side. So the value of 7 is what x would need to be in order for these to be congruent. Now, we can't technically say just from these being congruent that it is a parallelogram. We would need either parallel or also the other side sets congruent, but for just the information that's given and the question that's being asked, for just this pair of sides, x would need to be 7. For this example, there are 12 quadrilaterals and your job is to identify the parallelograms. So circle the ones that you feel are parallelograms and cross out the ones that are not. And I will provide the answers here in a minute. I do notice here looking at this screen that apparently I forgot to make edits to one of these quadrilaterals. So these two are the same. So obviously I see that, which is just a freebie, I guess. Whatever you do for this one, make that answer the same. This concludes the video lesson on the tests for parallelograms. So how can we tell if a quadrilateral is a parallelogram? Well, if it has any of the 5 properties or one pair of opposite sides that are both parallel and congruent, then the quadrilateral is a parallelogram.